Count to infinity is a serious problem, and it is bound to happen because the nodes which are running the distance vector algorithm do not look at the network as a whole, like number one, the link state routing algorithms. Number two, the neighbor-based information sharing takes its own time. That is why the count to infinity problem only can be solved, or the network converges to the true state of routing updates after these minimum iterations have been performed. In this module, we shall look at the routing loop situation from the point of view of the bad news, and then we'd look at the operation simply called poison reverse that prevents such loops, of course, to a certain extent. The reference is Quiroz and Ross. The only issue that we can understand is the bad news travels very slowly, and the link cost is large. That is, if the certain change in the link cost is very large as compared to the original cost, then the number of iterations required for the distance vector updates to converge would also be large. This is going to trigger back and forth, or the ping pong effect. It owes to the fact that the nodes involved in distance vector updates are blindfoldedly following what is told to them in the distance vector updates. In order to prevent such a situation from getting worse, a strategy is proposed, that is, one of the neighbors stops this whole back and forth communication by telling a small lie. That is, it poisons the link and makes that link unusable. Because of that, the loop is avoided. The operation can be understood like that. If Z routes through Y to reach X, Z is now going to tell a little lie. That is, Z tells Y that its distance to X is infinite. This lie will let Y know that Z cannot directly access X. Hence, the looping shall not be created. This looks quite intuitive, that if any change in link cost, especially towards the worst side, is created, including or incorporating such small lie telling, prevents the looping to be triggered. Is this a perfect solution for larger topologies as well? Well, it is not. Poison reverse does not work if more than 3 neighbors are involved in looping. And intuitively, it makes sense also, because Z was connected to 2 neighbors directly. But if Z is connected to more than 2 neighbors, which are again connected to each other, telling this lie on one node does not solve the problem, and loops can still happen at other neighbors. So more advanced techniques are incorporated, such as packet ID or broadcast ID. Using IDs, the routing updates are actually kept from spreading wrong information and causing loops.